Good evening, everyone. My name is K. Shankar. I am from the Department of ECE. Today I am telling about switching theory and logical design seminar. The topic is shift registers and the data movers of the digital signals. Table of the contents. There are the four types of contents: serial in, serial out, serial in, serial in, serial in, serial out, parallel in, serial out, parallel in, parallel out. Next, introduction of the sequential circuit. There are three types of sequential circuit. One is combinational circuit, sequential circuit. Combinational circuit. Output depends only in the present inputs. They now have the memory. Example, logic gates and adders. And the sequential circuits. Output depends on the present input and the past sequence of the inputs. They have the only memory. Example, latches, flip-flops, resistors. The need of the memory to state that the state, like the results of the calculations, are the hold temporary of the sequential circuits. And next, what is the shift register? Definition of the shift register. A group of interconnecting flip-flops used to store the shift from the binary information. Next, building block. The primary component in the D flip-flop in the one of the D flip-flop stores the data of the bitwise data. Then, the function of the data storage holds a group of binary bits. Example, 8 binary bit, 3 binary bit, 4 binary bit, and the n binary bits from the D flip-flop. And the data movements of the shifting moves the store the data from the position to the left or right with the every clockwise impulse. Next, the core components of the D flip-flop. The data of the D flip-flop is refers to the fact of the D flip-flops is fundamentally essential building block in the virtually of the all sequences digital electronic systems. This is about the D flip-flop of the components of the fundamental essential buildings and the key points of the D flip-flop. Function simplest flip-flop for the data storage of the at has a 1-bit operator from the binary memory of the unit operation. The output Q takes the value of the input D and the only will the clock pulse transformation of the example. Example low to high. The truth table represents in the D flip-flop. D flip-flop Q dash. 0 0 indicates 0 1. 0 1 indicates 0 1. And the 1 0 0 1. 1 1 indicates truth table of the 1 0. In the D flip-flop of the truth table. Next, in the sequential circuits, there are serial in, serial out. First, we see about serial in, serial out. There are four types. We will see first in, serial out. In the serial in, we have 64 bitwise serial in, and the serial out, we have shift register. The input data enters the register 1 bit at the time serially, and the output data exits the register on the 1 bit at the time of the typical from the last flip-flop serially. Operation for the n bit of the word, it takes that the clock pulse to load the data and the other n clock pulse to read it out. From the primary use the time delay elements of the delaying a signal of the cycles in the serial out in serial out. This is the representation of the logical design from the 64 bits serial in serial out of the shift register. Second one, serial in parallel out. This is called SIPO. The input is data enters the serially bit in the 1 bit at a time, and the output all the bits are available in the simultaneously in the parallel or from the Q outputs of the flip-flops and the operations of the serial in parallel out. Take n clockwise pulses to load the n-bit serial words. One loaded all the n bits appear instantly at the parallel output Q0 to Q3 etc. This is the representation of the serial in parallel and the primary user from the serial to the parallel conversion. A key function in the communication receiver, like converting a single stream of the data from the modern Wi-Fi chip of the used from the details of the register in the shift register. Next one. We will see the next one is parallel in series out. Input operator. All data bits are used to load simultaneously in the parallel into resistor in a single bit of the clockwise output. The data is shifted from the out of a 1 bit at a time serially. Operations required. We see the special control block usually multiplexer to switch the between load and the shift modes. This is the representation of the SN74LS 165 parallel series out in 8-bit shift register, and synchronous load. This is the representation of the logical design in the parallel in series out. We have the input, output, and the operations, and the primary use parallel to the series conversion. A key function is the communication of the transistor, like an 8-bit command from the CPU has a single stream over a wire. Next, parallel in parallel out, PIPO. There are input, output, function, and the loading readings primary use. This represented serial number is 74LS3995 in the parallel in parallel out. Shift register with the tri-state output. Input. Data is loaded simultaneously in the parallel. Output. Data is read to the simultaneously in the parallel. Function. Essentially a temporary storage unit, a buffer solution. Buffer rather than a shifter. It is the fastest mode for the loading of the reading data, and the loading is done in the clockwise pulse, and the reading is immediate. Primary use. Temporary data stored for the buffering different two components that operates the different speeds. You will tell about primary is the temporary data storage, the buffer between two components that operate the different speeds in the parallel in parallel or PIOP. Next one. Next, we will discuss about universal shift register, that is called as URS. What is the universal shift register? A single register that can be perform all the four operations. What are that four operations is single, series in, series out, and series in parallel out, and parallel in, series out, and the parallel in parallel out. There are the four different operations from the single register pulse using the holding of the universal shift register. The control is use mode control inputs, usually two or three selections lines, to choose the desired operations of the universal single shift. The examples are ICs. 74LS194 is a famous 4-bit universal shift register IC benefit from the maximum flexibility in a single hardware component, simplifying the larger circuit design in the universal shift register, that is also called as URS. Next, the key applications of the universal resistor shift: data conversion, sequence of the generation, and the arithmetic circuits. First, we will discuss about the data conversion. The core of the most digital communications of the data conversions are, there are examples are Bluetooth, USB, Internet, and the sequential generations, creating a specific timing of the pattern or digital waveforms in the sequence of the generation. And another one is called as arithmetic circuits, used in the multiplication and division operations to shift the binary number into binary operation and the binary number. This is about the key applications of the universal shift logic register. The conclusion. Shift register are the fundamental mechanism for storing, moving, and the reformatting binary data within any sequential. There are essentially link between speed of the parallel CPUs and the serial natures of the data transmission. This is about the conclusion of the shift registers are the fundamental mechanism for storing a moving and the reformatting binary data within any sequential system. They are called as the essential link between high speed parallel with the CPUs of the series nature of the data transmission. Data conversion, sequence generation, arithmetic circuits are the key applications. Thank you.